Hello, hi there. My name is Farah Diyana Binti Mohamad Fadzir. You can call me Fadi.
Hello guys, I'm Hanisah.
Hello guys, and I'm Amriena.
Hi, my name is Solehah. You can call me Santa Sol.
And we are computer science and mathematics students. Our video is about the difference between CPU and memory and the detail about these two components.
Our objective is the viewer can gain more knowledge about CPU and memory. You can also know how this part of computer operate in computer and how to difference between these two part of component.
CPU is known as Central Processing Unit. It is similar to the human brain. It interprets and carries out basic instructions that operate a computer.
CU stands for Control Unit. It controls and interprets the execution of instructions by following a sequence of actions that corresponds to the fetch-execute instruction cycle, which is it retrieves instructions from memory, then movement of data or address from one part of the CPU to another. It also directs the operation of the other units by providing timing and control signals.
In the CPU, we have ALU. ALU performs arithmetic and logical operation on input data. It performs this operation as directed by the CPU. The structure of ALU includes comparator, logic register, control of ALU, and the shifter. Comparator compares the magnitude of two numbers placed in the buffer registers. The comparator, used in conjunction with status registers, will output the result of the comparison. The logic register performs such logic operation as AND, OR, XOR, and many more. The control of ALU operates of ALU must be controlled. Accomplished through control leads that provide input path of control signs and facilitates the sequence and operation of each individual blocks of circuits. The shifter is a special function register. It will move the contents of a register one or more position left or right. It also can perform a unique operation called rotate when used with status register.
System clock is a device that emits periodic sequence of pulses to control the timing of all computer operations.
The fetch execute instruction cycle. Fetch known as find and decode instruction load from memory into register and signal ALU. Execute performs operation that instruction requires move or transform data. The fetch and execute contains three phases, which is phase 1 is fetch, phase 2 is decode, and phase 3 is execute.
If you like to move on to CPU processing method, there are three ways to increase the computer's performance. The first one is by separating the fetch unit or execute unit, then overlapping the instruction cycle of instructions. Lastly, executing more than one instruction in a clock cycle.
Memory is known as main memory or primary storage or working storage holds programs or instructions and data for access by the CPU. It is made up of a large number of cells, each which is on address.
The function of memory includes hold program that need to be executed, hold data to be processed by the CPU, and store the result from the process instruction.
There are two types of memory, which is non-volatile memory and second is volatile memory. The example of non-volatile memory is ROM, as known as read-only memory. Second is EEPROM, and third EEPROM, and lastly, flash ROM.
Example of volatile memory is RAM, SRAM, DRAM, and MRAM.
Memory capacity. The size of a memory is defined by the address SIM. If an address SIM has M bits, the maximum number of cells directly addressable is 2 power of M. Read operation. CPU copies an address from some register in the CPU to the memory address register MAR. At the same time, the CPU sends a message to the memory unit that the memory transfer is retrieval read from memory. CPU then momentarily turns on the switch that connects the MDR with the register, and transfer takes place between MDR and memory. The data will then be transferred to the appropriate register in the CPU. Memory content will remain intact, while the content of MDR will be replaced by the new data from memory.
Write operation. CPU copies an address from some register in the CPU to the memory address register MAR. At the same time, the CPU sends a message to the memory unit that the memory transfer is stored to memory. CPU then momentarily turns on the switch that connects the MDR with the register, and the data transfer that takes place between the register and MDR. The data will then be transferred from the MDR to the memory location as specified in the MAR.
Memory adjustment. Memory is slow compared to CPU processing speeds. Methods to improve memory access have 3, which is wide path memory access, memory interleaving, and cache memory.
The conclusion is CPU and memory have a different task to operate in the computer from the data input, but they also work together in the same time, especially to save the information in the memory. Next, both of the component computer use different methods to process the instruction. Lastly, they also have different methods to increase the computer performance.